Yes, dear student, now today let us start with the next concept, that is the important modern periodic law. Okay. So in earlier class or earlier video, we have discussed about the introduction of classification of elements. That is a Dubé runner, then Newland, and Mendeleev's periodic table. So now whatever we are using nowadays, that is nothing but a modern periodic table. It is entirely based on an atomic number. Okay. So what this law tells here? So modern periodic law, it states that the physical and chemical properties of the element are periodic function of their atomic number. So they have considered here, that is the atomic number. Henry Moseley, he has given this idea. So he has based on some experiment he has made. He has taken the frequency against the atomic number, square root of frequency. He has done some graph he has drawn with some atomic numbers and its frequency, square root of its frequency, and found that there is a relation with atomic number and a frequency. Hence he has derived this concept, that is based on the atomic number we have to classify the elements. Okay, and already you have studied in high school the same thing. What he has made is there is a groups, that is a columns, 18 columns. Okay, so on the left side we are in the two, that is the first and the second, first group and second group. Okay, then on the right side here is the 6, 1, 2, 3, 4, 5, 6 groups. Okay, and in between these two there are 10, and below here, okay, so there are two groups again, these two periods here. So like this he has made there is a groups and a period. So how many groups? 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 groups. 18 groups are made. And periods. 7 periods are made. Okay, further we are going to discuss about the with respect to the groups and the period. So then the first and second group, so those elements are called as a S block element. Okay, why they are called as S block, later on we can discuss. So these two groups, that is the first group and the second group. So this is the first group. First group, and this is the second group. Okay. These two group elements are called as what? S block element. Group 1 and 2 are called as a S block element. So which are present on the left side of the periodic table. Then extreme right side of the periodic table. So group number starts from here 13. So 1, 2 are 3 3, 4, 5, 6 like that. So from 13, 14, 15, 16, 17 and 18. So these groups comes on the right side. So they are called as a P block elements. Okay. Between S and P, so we are in a group is a 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these groups are called as a transition elements. So transition takes place. And most of these elements are metals. Okay. And these are called as a D block elements. D block elements. So these are called as a P block elements. They are called as a P block elements. Then below the main periodic table, we are having 2 periods or 2 rows. So those are called as the F block elements. And these are also called as the lanthanides and the actinides. Okay, the lanthanides and the actinides. So like this, he has made 18 groups. Just group idave totally 18 groups. First and second group are called as the S block elements. They are also called as the alkali metals and the alkaline earth metals. Okay. Then between this next is the third, fourth, fifth is the 10 groups. 10 groups are there. So those 10 groups are called as the D block elements, or they are also known as the transition elements. And the right side here we are in the P block elements, and 13, 14, 15, 16, 17, 18. So this 18th group element is also called as a noble gas. So that is called as a noble gas or inert gas, because the outermost shell is completely filled. Whereas the P block element here from 13 to 17, so these are partially filled. Incomplete shell, not the orbital. Shell is a incomplete. Okay. And why these are called D block element? Because the electrons, outermost electron enters into the D orbital. So therefore D block elements. Similarly, it is a F block element. So like this, they are classified. Then if you observe row, okay, horizontal line, row wise over there are 7 periods. So these are called as a groups. Periods. So first period we are having only 2 elements. First one is the hydrogen and a helium. So that is the shortest period. First period is the shortest period. Then the second and third period is having how many elements? So second period is having 1, 2, 3, 4, 5, 6, 7, 8. Similarly, third period is also having 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements each in the second and third period. So they are called as a short period. Next, the fourth and fifth. So they are having so how much? Plus 10, that is 18 elements each. They are called as a long period elements. And 6 and 7, they are having here also. That is the lanthanides and the actinides. So that is the extension of this. So that is nothing but they are having 32 elements each. Okay. Here 14 groups, 14 elements are there in each row. So like this, the modern periodic table, we are having these are the things, that is the groups and the periods. So 18 groups, where first group and second group are known as the S block elements. They are also called as metals. Alkali metals first group, second one is the alkaline earth metals. Okay. Then right side P block elements. So that is from 13 to 17 is a P block. 18 is also we are considering P block, but especially that is called as the noble gases. Okay. Where incomplete shell electrons are incomplete in the outermost shell. And one more property in P block elements, here we can find almost all type of elements. We can find solid, liquid, gas, then metals, non-metals, okay, metalloids. All type of elements can be found in P block elements. Okay. Then D block elements, so there are 10 because D orbitals. So there are 10 electrons accommodation takes place, so therefore 10 here. And ultimately last is a lanthanide and actinides. So lanthanide is atomic number 58 onwards, 58 to 71. Then actinides, so that is from 90 to 103. So like this, we are going to classify the elements. Now let us go for next here, how to name the nomenclature of the elements. So we know the researches are going on in all over the world. Different countries, they are in the search of that elements. ಬೇರೆ ಬೇರೆ ದೇಶಗಳು ಏನು ಮಾಡ್ತಾ ಇದಾವೆ, ರಿಸರ್ಚ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದಾವೆ. ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಅನ್ನು ಕಂಡುಹಿಡಿಬೇಕು, ಅದ್ರ ಹೇಗಿದೆ, ಅದ್ರ ಪ್ರಾಪರ್ಟಿ ಗುಣಧರ್ಮ ಹೇಗಿದೆ, ಇಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್, ಆ ರೀತಿ ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸೊ ಅಲ್ಲಿ ಕನ್ಫ್ಯೂಷನ್ ಶುರು ಆಗುತ್ತೆ. ಯಾವ್ಯಾವ ಬೇರೆ ದೇಶದವರು ಒಂದ್ ಕಡೆ ಅದೇ ಸೇಮ್ ಮಾಡ್ತಾರೆ, ಇನ್ನೊಂದು ದೇಶದವರು ಅದನ್ನೇ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. 4-5 ದೇಶಗಳು ಯಾವ್ದಾದ್ರು ಸೇಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಮಾಡ್ತಾ ಇರ್ಬೇಕಾದ್ರೆ ಅದಕ್ಕೆ ಯಾವ್ದು ಹೆಸರು ಕೊಡಬೇಕು, ಹೌ ಟು ನೇಮ್ ದಟ್. ಸೊ ದರ್ ಇಸ್ ಸಮ್ ಕನ್ಫ್ಯೂಷನ್ಸ್ ಆರ್ ದೇರ್. ಅವ್ರು ಒಂದು ಹೆಸರು ಕೊಡ್ತಾರೆ, ಇವರು ಇನ್ನೊಂದು ಹೆಸರು, ದೇಶದವ್ರು ಇನ್ನೊಂದು ಹೆಸರು ಕೊಡ್ತಾರೆ. ಅವಾಗ ಯಾವ ಹೆಸರನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು, ನಾವು ಮೊದಲು ಕಂಡುಹಿಡಿದಿದ್ದೇವೆ, ಅವ್ರು ಮೊದಲು ಕಂಡುಹಿಡಿದಿದ್ದೇವೆ, ಹೀಗೆ ಡಿಸ್ಕಷನ್ ಆಗ್ತಾ ಇರ್ತದೆ. So therefore IUPAC system, so they have developed in the beginning, so we have to name with some unknown, that is with some rules we have to find out. Just like ಮನೆಯಲ್ಲಿ ಮಗು ಹುಟ್ಟಿದ ಕೂಡಲೇ ಅದಕ್ಕೆ ಕೂಡಲೇ ಹೆಸರು ಇಡುವುದಿಲ್ಲ, ಅದಕ್ಕೊಂದಿಷ್ಟು ಟೈಮ್ ತಗೋತಾರೆ. ಒಂದು 12 ದಿನ ಆದ ನಂತರ ಹೆಸರಿಡ್ತಾರೆ, ಒಂದು ತಿಂಗಳು ಆದ ನಂತರ, 40 ದಿನ ಆದ ನಂತರ, ಹೀಗೆ ಹೆಸರಿಡ್ಲಿಕ್ಕೆ ಟೈಮ್ ತಗೊಳ್ತಾರೆ. ಸೇಮ್ ವೇ ಹಿಯರ್ ಆಲ್ಸೋ, ಬಟ್ ಅಲ್ಲಿವರೆಗೆ ನಾವು ಸುಮ್ಮನೆ ಅದಕ್ಕೆ ಏನೋ ಬೇರೆ ಹೆಸರನ್ನು ಕರಿತೇವೆ ಮೊದಲು. ಹಾಗೆ ಸೊ ಟು ನೇಮ್ ದ ಬಿಫೋರ್ getting to the actual name, so the IUPAC, so naming is done. So what are the rules to be followed while writing the IUPAC name? IUPAC naming ಮಾಡಬೇಕಾದ್ರೆ ಎಸ್ಪೆಷಲಿ ದಟ್ ಇಸ್ ಫಾರ್ ಮೋರ್ ದೆನ್ 100 ಅಟಾಮಿಕ್ ನಂಬರ್ 100ಕ್ಕಿಂತ ಹೆಚ್ಚಿಗೆ ಇರೋದು, ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಅಲ್ಲಿರುವ ಮುಂಚಿದೆಲ್ಲ ಕಂಡು ಹಿಡಿದಾಗಿದೆ, ಹೆಸರು ಕೊಟ್ಟಾಗಿದೆ. ಸೊ ನೌ ಇಟ್ ಈಸ್ ಫೌಂಡ್ ದಟ್ IUPAC they have made some rules to name the elements. So it is based on the atomic number. Atomic number ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿ ಅವರು ನೇಮಿಂಗ್ ಮಾಡ್ತಾರೆ. That is a temporary name. Finally the committee will decide what name is to be given. Okay. So ಒಂದು 104 ಅಟಾಮಿಕ್ ನಂಬರ್ 104 ಅದದೇನಾಯ್ತು, ಅಮೇರಿಕಾದವರು ಒಂದು ಹೆಸರು ಕೊಟ್ಟರು, ರಷ್ಯನ್ದವರು ಇನ್ನೊಂದು ಹೆಸರು ಕೊಟ್ಟರು. ಆವಾಗ ಡಿಸ್ಕಷನ್ ಯಾವ್ದು ಹೆಸರು ಇಡಬೇಕು ಅಂತೇಳಿ ಕನ್ಫ್ಯೂಷನ್ ಶುರು ಆಯ್ತು. ಸೊ ಆವಾಗ ಆ ಕಮಿಟಿಯವರು ಡಿಸೈಡ್ ಮಾಡಿ ಈ ರೀತಿ ಇದನ್ನ ರುದರ್ಫೋರ್ಡಿಯಂ ಹೆಸರು ಕೊಟ್ಟರು. ಸೊ ರಷ್ಯಾದವರು ಅವ್ರದೇ ಹೆಸರು ಕೊಟ್ಟಿದ್ರು ಅದಕ್ಕೆ, ಅದರ ಹೆಸರು ಕುರ್ಚೋಟಿಯಂ ಅಂತ ಹೆಸರು ಕೊಟ್ಟಿದ್ರು. ಇವರು ರುದರ್ಫೋರ್ಡಿಯಂ ಹೆಸರು ಕೊಟ್ಟಿದ್ರು ಅಮೆರಿಕದವರು. ಅಲ್ಲಿ ಅಮೆರಿಕದ ಹೆಸರು ಸರಿಯಾಗಿ ಅದನ್ನು ಒಪ್ಕೊಂಡ್ರು. ಸೊ ಲೈಕ್ ದಟ್, ಸೊ ಬಿಫೋರ್ ನೇಮಿಂಗ್ ಎ ಆಕ್ಚುಯಲ್ ನೇಮ್, the some elements, that is elements are given with some temporary name. How to name that? That is based on the atomic number, and it is having a 3 alphabet, because it is based on the atomic number. We have to name that, and also the word ends with the IUM, just like potassium, sodium, ಕ್ಯಾಲ್ಸಿಯಂ, ಮೆಗ್ನೀಷಿಯಂ ಹೇಳಿದಂಗೆ IUM ನಿಂದ ಎಂಡ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ಟೇಕ್ ವಾಟ್ ಆರ್ ದ notations and what are the rules to be followed. Okay, I hope you have followed this. So just go through the textbook how the elements are distributed in the modern periodic table. Okay. Further we are going to discuss once again the group and period wise electronic configuration. So here also they are classified based on its electronic configuration only. So here we are getting the S1 electrons. The outermost electron is in the S orbital with only one electron. This is the S2, NS2. Then P1, P2, P3, P4, P5, P6. This is D1, D2, D3 like that. Electronic configuration ಮೇಲೆ ಇದನ್ನ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಿದ್ದಾರೆ. Nomenclature of elements. With the atomic number more than 100. Atomic number more than 100 is there. Okay. So what are the things here we have to consider? Notation. How to write up this in terms of the symbolical notation. Digit 0, its name un, symbol u. Sorry. 0 is a nil, it is n. 1, that is a un. 2, it is a y. 1 0 is a nil helbeku, the symbol is a n, and 1 is a un u, 2 is a y, 3 try, 4 quad, 5 pent, 6 it is hex, 7 sept, 8 oct, 9 n. So we have to follow this. So 0 idaga adana nil anta helbiಟ್ಟು symbol is n, 1 idaga un, symbol is u, 2 idaga by, b, 3 idaga try, t, 4 idaga quad, q, 5 idaga pent, p, 6 idaga hex, h, 7 idaga sept, 7, s, 8 idaga oct, 9 idaga n. So these are the notation we have to follow. Next the name should end with the IUM. Name should end with the IUM. IUM, that is a potassium, magnesium, calcium, like that. Is a name should end with the IUM. And the symbol is derived from its atomic number only. Okay. So these are the things we have to follow while writing the IUPAC name of atomic number more than 100. So let us take some example of this now. Okay. Atomic number 101. So what is the symbol or name of this 101 idaga? 1 first starts with 1 means un, next is 0 nil, un nil, but once again it is 1 means again un, last is a IUM, nil anium. Symbol is a 3 letters. So what is the symbol is here? It is a U, capital U barabeku first, then nil, UNU. Follow 101, 1 andre U, 0 andre N, again 1 U. So UNU. And how to name this? 1 means un, 0 means nil, nil, but once again 1, un. Last ends with the IUM, nil anium. 102. un, nil, bium. Symbol U, N, B. Okay. Next 103. Un, nil, trium. U, N, G. 104. Un, nil, quadrium. Symbol U, N, Q. Okay. So like this, we have to name the and write the symbol. Okay. So now we know this. These are already known things. So they are having some separate name for that. That is a Mendelium, then Nobelium, Lawrenceum, like that. Suppose if I take write the 1 mark question may be asked on this. Write the symbol or write the name of atom having a 116. Atomic number 116 is right number. Once again, hexium. Symbol U, H. Serena. So like this, or they may give this. You have to write this or this. So U for un. Okay. Normally 100 values in the first starts with the un only. U dindane bartade. Then 0 barbodu 2, 3, 4. That is the left. Okay. So this is how to name the elements which is having the atomic number more than 100. Okay. Just you have to practice this.